Okay, so now as we are proceeding with our PERT chart, I'm sure now things are starting to be interesting and you are trying to understand how these particular things work. Remember, we'll be breaking down the concepts as we proceed. So continuing doing our CYS330 test 2 answers. So basically now we need to proceed. Okay, so we did question 1A up to D now, so we proceed to the next part of the question. So question 3 now from this particular test 2 paper is still on PERT charts. So the question reads, activities of a remediation plan have been assigned to you to come up with the project network, which is scheduled to be presented in a managing system meeting. So draw a network diagram for the remediation project, 5 marks. So drawing now is not a problem, so let's just draw it faster. So now whatever we are doing at first, we were having a situation where we were using letters such as A, B, C, whatsoever. Now here we have numbers instead of letters. So let's see how we can deal with this one. So we open our Hydromax, and then once we open our Hydromax, we start with a blank project, just search for PERT chart. Then remember, this is the symbol we'll be using. Now, as I've said, for our PERT chart, we'll be always starting with the starting point, which is node number 1. Now we can start. So these activities which you've been given are using numbers. So since we already have our 1 on our Hydromax, we can just say, okay, 1 is repeating 2 times, okay? So 1 is having a node 2 and 3, meaning 1 should be attached to node 2 and 3. So we go to our Hydromax, then we need to say 1 should be attached to node 2 and 3. So this is what we do. So we'll say this is, sorry for that. So let me use the normal connector. So this we can say that's our node 2 and this is our node 3. Now instead of representing them on the lines like letters, we'll be using the normal way we represent nodes with numbers. So we are saying node 2 and 3 are coming from node 1. That's the first statement we have. Now we can see the next statement is that 4 is coming from node 2. 4 is coming from node 2. So we go where there is our node 2, and that's where our 4 should come from. So we do this. So node 4 is coming from this node, which is node 2. So we'll say 4. Okay. Now once that is done, we go to our next activity. So node 4 again is coming from node what? 3. Okay. So I go back in our Hydromax. So this is node 3 and node 4 should also come from this node. So what we do, we just do this. We represent that with this. So we are simply saying node 4 is coming from both 2 and 3. Okay. Now we can see that 5 is coming from node 2. 5 is coming from node 2. Now notice that our 2 is here. So here what I need to do, maybe I can just drag this at the bottom like that, such that we give space for our node 5. So node 5 can be there. So we know that 5 is coming from 2. So we need to represent it very nicely. So 5 is coming from node 2. Now the last one, node 5 is also coming from node 4. So what we need to do now is that we already have 4 and 5 should come from 4. So 5 is coming from both node 2 and node 4. So we are done with drawing our network diagram. Now this time around we have the durations. Okay, we have the durations. Even at first I remember the duration. Okay, so now here for the durations, we'll start from 1 to 2. It is taking us 13, that's the duration. I'm not sure if it's hours or days, so it's taking us 13. That's the time, the duration. So from 1 to 2 we have 13. So say from 1 to 2 we represent 13 on this particular arc. Why? Because now we don't have letters, so it's just normal to do that. Then our next activity 1 to 3 is 12 in terms of the duration. 1 to 3 is 12. So 1 to 3 is 12. So we can just put 12 there. Let's go to the next duration. So 2 to 4 is 2. So it's supposed to be closer to each other, I assume. 2 to 4, is it 2? It's what, 3? 2 to 4, 2. 2 to 4, the duration is 2. So this wasn't supposed to be too far from each other because of the duration. So let me see how I can make this possible. So because 13 is longer and 12 is also longer but not like 13, maybe I can try to do that. Okay, but we are saying this node just as in terms of duration is 2. Maybe I can try to do this so that we have a duration of 2. So let me continue. Now 3 to 5 has a duration of 8. 3 to 4 duration is 8. 3 to 4. So 3 to 4 duration is 8. So this can make sense for this duration of 8. So this duration can make sense for the duration of 8, I guess. And then okay, now let's so 2 to 5 we have a duration of 15, so that one should be longer, 15. So I'll just drag. So I'm trying to make these things more realistic, but when it comes to drawing on paper, the way it was at first, just leave it like that, there's no issue. Okay, now we have 4 to 5 which has a duration of 2, so that's supposed to be closer. 4 to 5 a duration of 2. So what we can do, maybe we can do this. Okay, so just a minute, just trying to make sure that these things are making sense. Okay, so at least from our durations, maybe this is making a little bit sense in terms of the durations. Okay, now that we have our PERT chart diagram in place, we can now try to see the next question. So since we have the durations, we know that we need to calculate both the forward and the backward pass, but we are not in a hurry. Let's just follow the questions. So our first part was draw the network diagram for the remediation plan. Now our second part is determine the critical path. So let's just start with determine the critical path. So there's no need to define, you already know what's a critical path. So for the critical path, what to do, remember the first node will start at 0. Now in a forward pass we add, we'll say 0 plus 13, we are getting 13. Okay, then we'll say 0 plus 12, we are getting 12. Okay, the next node is 4. Now notice that 4 can be coming, 4 can come from 2 and also 3. So we need to make a decision. So in a forward pass, we said we get the maximum value after adding. So say 3 plus 2, it's 15. But what about 12 and 8? It's 20. So we put 20 there because 20 is our maximum value in the forward pass after adding. Now the next node is 5. Notice 5 is coming from 4 and 2. So we need to make a decision. 20 plus 2, it's 22. But 13 plus 15, we have 28. So 28 happens to be our maximum value. So we say 28. Now we start the backward pass. So in a backward pass, we say it will be subtracting, but when we have a tie, we make a decision by getting a minimum value. So since it's in reverse, we also start at 28. So we say 28 minus 15. Okay, before we even go there, we say 28 minus 2, which is giving us 26. So here we have our 26. Now, why have I said before even go there for this one? Is because even 4 is giving 2 and 5 is giving 2. So if we say 26 minus 2, the answer is 24. But what about 28 minus 15? The answer is 13. So we put 13 there because it's our minimum value when it comes to the backward pass. Now, let's say 26 minus 8. We get 18. So I'll put 18 here. Then let's try to say 18 minus 12. The answer is 6. But what about 13 minus 13? The answer is 0. Meaning our backward pass, we get the minimum value. So we are done calculating this. Now notice that always the starting point should have 0, 0. Then the ending point should have the same number or the equal number. Otherwise, if that's not the case, it means it's wrong. Okay. Now, before we go to the critical part, we said we need to know the slack. So the slack is simply the difference, as we've said in the previous video. So a slack is simply 0 minus 0. We have 0. We go to the next node, which is 2. What's the slack? So we say slack. So 13 minus 13, it's a 0. We go to the next node, which is 3. So what's the slack for this one? So we say slack. So I'm sure, let me just check. We cannot see this. Let me drag it here. Okay, so we have 18 minus 12. 18 minus 12, which is giving us 6. So here we put 6. Okay, 18 minus 12, 6. We go to the next node, which is 4. So we say slack. So our slack is 26 minus 20, which is 6. Okay, 26 minus 20, which is 6. Then the last one is 28 minus 28, which is giving us a slack of 0. Now, we said the critical path is anywhere where we have a slack of 0, and that's where we shade. So from 1 to 2 we have 0, 0, meaning here it's okay, we can shade it because the slack has 0, 0, which can represent our critical path. Okay, now notice that even on here where we have 1 to 3, it's not 0, 0, it's 0, 6, so we skip. Then even here where we have 6 to 0, we skip, but here we have 0 and 0, so this one can be shaded. Okay, so I'll just repeat that, otherwise there's nothing to be complicated here. Now here I have a slack of 0, here 6, so we cannot shade. So what we mean is that from 1 to 2, we can see 1 is 0, the slack, and 2 is 0, so we can shade here, it's okay. But from 1 to 3, the slack for 1 is 0, for 3 is 6, so we cannot shade here, it's not 0, 0. And for 2 to 4, we can see that 2 has a slack of 0, but 4 has a slack of 6, so we cannot shade. But 2 to 5, we can see that 2 has a slack of 0, 5 has a slack of 0, so we can shade. Now we come to 4 to 5. 4 has a slack of 6, 5 has a slack of 0, so we cannot shade that. Now we can represent our critical path. So we say critical path is equal to what? So from 1 to 2, yes, we have a critical path. So I'll say 1, 2, 2. And again, we can see from 2 to 5, we have a critical path. So I'll say 2 to 5. That's our critical path. So officially, we have our critical path is from 1 to 2 to 5. Okay. Now let's proceed with the question. So it's saying, and find the earliest start time, earliest finish time, latest start time, and latest finish time, 10 marks. So now this is where we introduce the actual names for those things. We were saying that those values when subtracting the slack. So what we need to do, we need to come up with something first. Let me put at 20 again. Okay, so we need to have our activities in line. We need to have our activities. So we need to have our activities. Now, after our activities, we need to have the earliest time, which is ES. Let me just do this. Let me just do something here. I want to explain something before we even start this. So remember, we were saying we have two things, backward pass and forward pass. So in this case here, we are talking about the backward pass. Why is it the backward pass? I'm going to explain. So in the backward pass, so we need to have the activities first. Activities. Let me just come up with this, then it will make sense. We need to have the earliest start time. We need to have the duration, which will be represented by small letter t. Then we need to have the earliest or the earliest finish time. Okay, earliest finish time. This is what we need in the backward pass. So let me merge that. Okay, so now, sorry for that, just need to make sure that everything is neat. Okay, now in a backward pass, let's start with the activities that we have faced from the question. So I'll go back to the question, the one which had the data. So where is the question? So our activities, we have 1 to 2. Okay, so say 1 to 2, 1 to 2. Okay, our first activity, we have 1 to 2. Okay, then the next activity which we had is 1 to 3. Okay, so say 1 to 3. Then the next activity which we have is 2 to 4. So there we'll put 2 to 4. 2 to 4. Then the next activity which we have 3 to 4. So say 3 to 4. 3 to 4. Then the next activity we have 2 to 5. So we say 2 to 5. Then the next activity we have 4 to 5, which is the last one. We say 4 to 5. Now notice that T represents duration. So the duration, we already have our durations. Okay, so our durations is 13, okay, 12, 2. So 13, 12, 2. I'm following that order. 13, 12, 2. Now what's coming next? We have 8, 15, 2. 8, 15, 2. 8, 15, 2. Okay, perfect. Now in a backward pass, we have two concepts. We have the earliest start time and the earliest finish time. So remember, in a backward pass, why am I saying backward pass? Sorry for that. Forward pass. Forward. Yeah, forward pass. So in a forward pass, we have two concepts. We have the earliest start time and the earliest finish time. Okay, now let's go back to our hydromax. We understand these things. So from 1 to 2, the earliest start time will be getting the values at the bottom. Okay, because when adding, we are using these values on the bottom. For example, 0 plus 12, 12, we have 12 there. So meaning our lower section was used in a forward pass. Okay, depending on whatever you do, just notice that. So in a forward pass, we concentrate on these numbers which are here. So where there is 1, we just say what's on the bottom. So you can see on the bottom we have 0. That's our earliest start time. Now you know that's the earliest start time. So it says 0. Notice here we also have 1 at first. So we just put 0. No waste of time. So now let's go where there's 2. So you can see here where we have 2, on the bottom we have 13. So we just do that. We put 13. So again here we have 2. We can put 13. Here we have 2. So there's 13. Let's go where we have our 3. So at the bottom there we have 12. So we can put 12. So 12. Then let's go where there's 4. So where is our 4? So 4 is here. At the bottom we have 20. So there we just put 20. Okay. Now EF as a formula. So the formula for EF, which is the earliest finish time, is simply ES plus the duration. Why are we saying ES plus the duration? Is because in the forward pass we are adding. So when we say 0 plus 13, the answer is 13. That's our earliest finish time. 0 plus 12, the answer is 12. 13 plus 2, the answer is 15. 12 plus 8, the answer is 20. 13 plus 15, the answer is 28. Then 20 plus 2, the answer is 22. So these are the values which we are getting in the forward pass. Okay, hope this has made sense. Now our question is not just telling us to add the ES and EF, no, but also the LS and the LF. Okay, now LS and LF comes in where we have the backward pass, okay, where we need to subtract. So again, we'll just create this thing called backward pass. So in our backward pass, sure, we have the activities. That's no doubt. We need to have our activities. Yes. So apart from the activities, we don't need to have the ES. Remember, you were dealing with the LS and the LF. Now here I'll start representing the LF. I'll explain why. Then here I'll put the duration, and here I'll put the ls. Okay, now let me just make this look nice. So we need to merge this, also put it in bold. So even this is supposed to be in bold, just for them to look neat. Okay, now the activities you already given, these are the activities we have. Okay, so the activities we have them, these are the activities. Now even the time, we already have our time. This is our time, nothing can change. So the time, already have the time again. So now the latest finish time in the backward pass, we are simply saying we'll concentrate on these numbers, not these now, but these ones after the first ones. So we go where there's 2, our node 2. So where there's 2, instead of getting the lower one, we'll get the upper one. So it's 13. So put what? 13 there. So do we have 2 this side here? No. So let's go on 3. So again, we'll go on node number 3. So node number 3, where is it? We'll take 18, which is the upper one, as our LF. So get our 18 there. Then we have 4 now. So we go where there's 4. We'll get 26 there, upper. So we have our 26. We'll say 26. And again here we have 4. So 26. The last 3 we have our 5, for which we know it's 28. So 5 upper there we have 28. So get our 28. So we'll say 28, and there again we'll say 28. Now ls, which is the latest start time. So in the backward pass, remember we are subtracting, so it will be latest finish time minus the duration taken for this activity. So it's just simple. In forward pass we add, in backward pass we subtract. So we'll say 13 minus 13, 0. 18 minus 12, 6. 26 minus 2, 24. 26 minus 8, 18. 28 minus 15, 13. 28 minus 2, 26. So these are our digits in terms of the forward pass and the backward pass. It means we've answered this particular question, which is 10 marks, just to calculate that. Now we don't end here, things are starting to get interesting. Now this question is supposed to be here now. So the question now is telling us to say calculate the total float, free float, independent float, and interference float. Okay, so these things, if you want to understand them in terms of the definitions, you can read out the handouts, which are valuable. You know where to access them. Just go on the about year 3, then system vulnerability assessment. You are going to find these notes. So now we need to calculate for these things. So what we'll do is that we need to come up with another table. So obvious, this table will start with activities. Okay, let me just start this table here. So the table starts with activities. Okay, now we have what we call T and H. I will explain. Then here we have LS. Here we have ES. I will explain everything. Then here we have TF, total float, free float. Then independent float, then interference float. Okay, now the activities, you already know that activities, we simply mean these activities, so there's no need for me to explain that. So those are the activities we are given. So the activities already have them. Those are the activities. Now here we have T and H. So these are slacks. So these are slacks. So we already know what a slack is. So let me just merge this. Okay, so T and H are slacks. So T, we are simply saying it's a tail slack, and H is the head slack. Okay, now notice that we have LS, which is the latest finish time, latest start time, by the way. So LS has been calculated, so we can just get these values and paste them there. Then again, ES, which is the latest start time, we already have it, which is here. So get these values, paste them there. Then now we need to identify the tail slacks. So for us to identify the tail slacks is that we'll be focusing on these activities here. So we go where there's 1. What's the slack for node 1? So you can see the slack for node 1 is 0. So we just put a 0 there, and here you can see this is a 1. Again we put a 0. Now we go to 2. Okay, so on 2 we can see that the slack for node 2 again is 0. So there we just put a 0. Then we can see 2 here again, so we put a 0 in advance. So now we go to node 3. So on node 3 we can see that the slack is 6. So there we'll put 6. The lastly on this node, which is node 4. So on node 4 we have a slack of 6. So what to do on node 4, since we have a slack of 6, we put a 6. Now for the head slacks, these are the things we'll be considering. Okay, so we'll start with 2. So we'll go where there's 2. So 2, you can see that the slack is 0. So we put our 0 there, here. Then we have 3. So what's the slack for node 3? You can see it's 6. So there we put 6. Then we have 4. So what's the slack for node number 4? So the slack for node number 4 is 6. So there we put 6, and here we put 6 again, because here we also have 4. Now what's the slack for 5? So the slack for node number 5 is 0. So here we put a 0, and here we put a 0. Okay, so you can see that 5 has the slack of 0. Now we come to the total float. So for us to calculate a total float, we have two formulas. It's either, you can say, total float is equals to LS minus ES. Okay, let me just do this. Okay, so for total float, it's either, you can say, this LS minus ES, or you can say LF minus EF from these values we calculated. So we are going to go with this one in our case. Okay, so what is 0 minus 0? You get a 0. What is 6 minus 0? You get a 6. What is 24 minus 13? 11. So what is 18 minus 12? 6. 13 minus 13, 0. 26 minus 20 is 6. Okay, so we have our total float. Now we have the free float. So a free float again has a formula. So for a free float, let me just take this one. Sorry for that. So Now I was saying free float, which is FF, as the formula. So we say total float minus head slack. Okay, so that's the formula. So we are saying free float is total float minus head slack. So this is our free float and this is our head. So we say 0 minus 0, so becomes 0. Now we say 6 minus 6, so which is a 0. Then we say 11 minus 6, which gives us 5. Then we say 6 minus 6, which gives us a 0 again. Then we say 0 minus 0, here we get a 0. Then we say 6 minus 0, where we are getting a 6. Okay, so this is our free float. Now we have the independent float. So again, independent float as a formula. So independent float is simply free float minus tail slack. Free float minus tail slack. Okay, so free float minus tail slack. So this is our free float, these are our tails. So 0 minus 0, here we get a 0. Then we say 0 minus 0, again here we get a 0. Then 5 minus 0, we get 5. Then 0 minus 6, we get negative 6. Then 0 minus 0, we get 0. Then 6 minus 6, we have a 0. So that's our independent float. Now what about the interference float? So interference float is equal to total float minus free float. Okay, total float minus free float. So since here we are saying total float minus free float, here we simply say this is our total float. As we can see, this is our free float. So it will be, this is our total float, by the way, total float, this is our free float. So it's 0 minus 0, we are getting a 0. Then you have 6 minus 0, we are getting 6. And then 11 minus 5, we are getting 6. And then 6 minus 0, 6. And then 0 minus 0, which is a 0. And lastly 6 minus 6, which is a 0. It means we are done with this question D. Okay, so for this question, I'm sure this is where it ends. Okay, now the next question which I'm going to do is based on this optimistic, pessimistic, and the most likely time. So my name is Asoko James, representing KMU Cybersecurity Tutorials, and make sure you watch this next video because it's the last video in the CYS330 test 2 answers. Thank you.